Hi friends, today we will be doing a problem on kruskals algorithm. Kruskals algorithm is used to find the minimum cost spanning tree of a given graph capital G. So here we are given a graph called as capital G. It has a set of vertices and edges. Now we have to find a minimum spanning tree or minimum cost spanning tree from this given graph. And the algorithm that we are going to use is called as kruskals algorithm. This is one of the algorithms that we used to find minimum cost spanning tree. Other than kruskals algorithm, another algorithm is also available for doing the same. It is called as Prim's algorithm. And in kruskals algorithm, there are a definite number of steps, and after performing those steps we will get a spanning tree, and the property of that spanning tree is that the sum of weight of edges in that spanning tree will be minimum. That is why it is called as minimum cost spanning tree. So here in kruskals algorithm, what we are going to do is, first of all we have to arrange all these edges present in the graph in ascending order. So you can see here that I have arranged all these edges in ascending order. So the least or the smallest edge is 5. You can find two edges with the same weight. So if multiple edges are there with the same weight, you can take them in any order. It doesn't matter. So here I am taking the least edge as edge AD, then next edge CE, then comes the edge with weight 6, which is DF. Then you can find two edges with value 7 or weights 7. I am taking the first one as edge AB, then second one as edge BE. Then you can also find two more edges with two edges with weight 8. I am considering the first one as edge BC, the second one as edge FE. Also you can find two edges with weight 9. I am taking the first one as edge EG, the second one as DB. Then the edge with weight 11 is called as FG, and with the 15 weight the edge will be DE. So here I have arranged all these edges in ascending order of their weight. Now what we have to do is to select an edge from this given list in such a way that no cycles are formed. We have to choose the edges from left to right, from the least to the largest, and with each selection we have to make sure that the addition of that edge to the tree should not create a cycle or circuit. So here first of all we will be considering the first edge with the weight 5. Let's consider edge AD. AD can be added to the spanning tree. Here I am specifying the spanning tree with red color. So addition of AD will not create any circuit in the spanning tree. Therefore AD can be added. Next step, we will be considering the edge with weight 5, which is CE. CE can be added to the spanning tree. CE can be added and it will not create any circuit in the tree. Therefore CE also can be added to the spanning tree. No circuits are formed. The next edge that should be considered is edge DF, which has weight 6. Edge DF can be added to the spanning tree. It will not create any circuit. Therefore DF can also be added to the spanning tree. The next edge that we are considering is edge AB or BE. In either way we can consider. So here I have taken AB as, I have written AB as AB in the first position, though, therefore I am considering edge AB first, only then I will consider edge BE. It doesn't matter in what order you take those edges. You can take those edges as you like. So here let's consider edge AB first. So AB can be added to the spanning tree. Circuits are not formed. AB can be added to the spanning tree. Now consider edge BE. Edge BE can be added to the spanning tree. No circuits are formed. Edge BE can be added to the spanning tree. Now consider edge BC. Edge BC, if added to the spanning tree, will create a circuit. A cycle or circuit will be created if I add edge BC to the spanning tree. But it is not possible, since we are trying to create a spanning tree, and trees are graphs without circuits. Therefore, a spanning tree must not contain any circuits. So, if we add BC to the spanning tree, it will create a circuit, and therefore it cannot be added to the tree. Therefore, BC can be discarded. BC cannot be added to the spanning tree. Then consider edge FE. FE has the same problem. If I add FE to the spanning tree, it will create a circuit as shown here. Therefore, circuits are created and FE should be discarded. FE cannot be added to the spanning tree. The next edge that we are trying to consider is edge EG. Edge EG can be added to the spanning tree. It will not create any circuit. Okay. Now we have understood that the graph has become connected. That means all the vertices are now being added to the spanning tree. Therefore, we can stop the algorithm right now. Further computations doesn't matter. Even if we try to complete or even if we try to check for adding the edges DB, FG and DE, they won't be able to be added to the spanning tree, since DB will create a circuit here. FG will where is FG? FG will create another big circuit. DE will create another circuit. Therefore, adding any of those edges will create a circuit. Therefore, we cannot add those edges. The algorithm can be stopped whenever all the vertices are added to the spanning tree. Therefore, what we are seeing in the red color is called as the spanning tree or minimum cost spanning tree of the graph capital G. And we have to calculate the sum of edges present in the spanning tree. So here in the spanning tree there are several edges with different weights. There is a edge with weight 5, another with weight 6, another with weight 7, another with weight 7, and another with weight 9, another with weight 5. So total there are 1, 2, 3, 4, 5 and 6 edges are there. So we have to find the sum of weights of the spanning tree. Sum of weights of the edges of the spanning tree. So here the sum we obtain is 6 plus 5, 11, 11 plus 7, 18, 18 plus 7, 25, 25 plus 9, 34, 34 plus 5, that will be 39 will be the sum of weights of edges present in the minimum cost spanning tree. And one thing also should be added. Here we have chosen edges in different order. We have seen that where the weights.